What if I told you that the very act of looking at something could change its past? It sounds like something ripped straight from the pages of a sci-fi novel. But this is the mind-bending truth at the heart of quantum mechanics. Picture a world where particles exist in multiple states at once until you observe them, forcing them to choose a reality. This isn't just theoretical speculation. It's the core of one of the most astonishing experiments ever conducted, the quantum eraser. For decades, this experiment has baffled scientists and philosophers alike, suggesting that reality might not be as fixed as we once believed. Instead, it hints at a universe where observation doesn't just record events, it might actually create them. Think about that for a second. The idea that our consciousness could play a role in shaping the fabric of reality is enough to send shivers down your spine. It challenges everything we thought we knew about cause and effect, time, and even the nature of existence itself. The quantum eraser experiment doesn't just ask us to rethink physics, it invites us to reconsider what it means to be an observer in a universe that seems to respond to our gaze. What happens when we peer into the quantum realm? Do we collapse possibilities into a single reality, or are we somehow co-creating the world around us? These questions aren't just academic. They strike at the heart of what it means to be human in a cosmos far stranger than we ever imagined. So buckle up, because we're about to take a deep dive into one of the most provocative experiments in modern science. We'll explore how light particles behave when no one's watching, and what happens when we suddenly start paying attention. We'll unravel the cosmic implications of these findings, from the nature of time to the possibility that reality itself might be a kind of grand illusion. And most importantly, we'll ask the big question: does observation create reality, or is there something even more mysterious at work? This isn't just a story about physics. It's a journey into the unknown, where the boundaries between the observer and the observed blur into something extraordinary, ready to have your mind stretched. Let's begin. To understand why the quantum eraser experiment is so revolutionary, we first need to grasp the bizarre rules that govern the quantum world. At the tiniest scales, particles don't behave like the solid, predictable objects we're used to. Instead, they exist in a fuzzy, undefined state, a blend of all possible positions, speeds, and even identities, until something forces them to choose. This is the principle of superposition, and it's as strange as it sounds. Imagine tossing a coin, and instead of landing on heads or tails, it hovers in mid-air, spinning endlessly as both possibilities at once. That's the everyday absurdity of the quantum realm. Now, here's where it gets even weirder. When scientists send particles like electrons or photons through a barrier with two slits, they don't just go through one or the other. They act like waves passing through both slits simultaneously, creating an interference pattern on the other side. But the moment you try to measure which slit the particle actually went through, that interference pattern vanishes. The particle suddenly picks a path as if it knew it was being watched. This is the infamous double-slit experiment, and it reveals something profound. Observation doesn't just record reality, it somehow changes it. This isn't just a quirk of tiny particles. It suggests that at the most fundamental level, the universe doesn't settle on a single version of events until someone or something takes a look. It's as if reality itself is fluid, a tapestry of possibilities that only solidifies under the gaze of an observer. And that's the key to unlocking the quantum eraser's mystery. If observation collapses these possibilities into a single outcome, what happens if we try to undo that observation? can we reverse the collapse and restore the original, undefined state? The answer will challenge everything you think you know about cause, effect, and the very nature of time. By now, you might be wondering who or what counts as an observer. Does it have to be a conscious being, or could a machine trigger this collapse? These questions lie at the heart of quantum theory's greatest debates. Some argue that consciousness itself plays a role in shaping reality, while others insist it's simply the interaction between particles that forces a definite state. But one thing is clear: the quantum world operates by rules that defy our everyday intuition, and the quantum eraser takes those rules to their most shocking extreme. So hold onto your seat, because what comes next will twist your understanding of reality even further. The double-slit experiment is where the quantum world stops playing nice with our everyday intuition. Imagine firing tiny particles, electrons or photons, one by one toward a barrier with two narrow openings. You'd expect each particle to go through either the left slit or the right one, like bullets through a target. But that's not what happens. Instead, when these particles aren't being watched, they do something extraordinary. They act like waves passing through both slits at once. On the other side, they interfere with themselves, creating a striped pattern of highs and lows on the detector screen. This interference is the signature of a wave, as if each particle is somehow in two places simultaneously, overlapping with itself. Now here's the twist that shook physics to its core. The moment you try to peek, to measure which slit each particle actually goes through, the interference pattern vanishes. The particles suddenly pick a side, behaving like ordinary objects rather than spread out waves. It's as if they know they're being watched. This isn't just a quirk of measurement tools, it suggests something far deeper. The act of observation, of gathering information, forces the universe to make a choice. Reality isn't fixed until we look at it. This brings us to the quantum eraser's radical question. What if we could take that observation back? What if, after measuring which slit a particle took, we could somehow erase that knowledge? Astonishingly, when physicists tried this, the interference pattern reappeared. It's as if the universe hit the undo button, rewinding the collapse caused by observation. The implications are staggering. It hints that causality, the idea that causes must come before effects, might not be as rigid as we thought. Could future actions influence past events? Could reality remain unsettled until all possible observations are accounted for? Some interpretations suggest that time itself might be more fluid than we imagine, with the present reaching back to reshape the past. Others argue it's not about time travel, but about the fundamental nature of information. Until a quantum system's history is recorded irreversibly, its story remains unwritten, open to revision. The quantum eraser doesn't just challenge our grasp of physics, it blurs the line between what's real and what's possible, leaving us to wonder, is the universe a cosmic game of choices, where every observation locks in a path and every erased observation unlocks it again? This experiment forces us to confront the uncomfortable truth that at the quantum level, reality might not exist in a definite state until it's observed, and that even then, it might not stay settled. Whether it's conscious observers shaping reality or simply the unavoidable disturbance caused by measurement, one thing is clear: the quantum world operates by rules that defy our deepest instincts about how the universe should work. And if these rules hold, they might not just describe tiny particles, they could rewrite our understanding of existence itself. The quantum eraser experiment takes the already mind-bending double-slit scenario and cranks up the weirdness to 11. Picture this: scientists set up the classic double-slit apparatus, but with a twist. After particles pass through the slits, they add a device called a quantum eraser, a mechanism that can either reveal which path a particle took or scramble that information after the fact. Here's where things get truly wild. When the experimenters choose to erase the which path data, something miraculous happens. The interference pattern, that signature of wave-like behavior, suddenly reappears on the detector screen. It's as if the particles somehow remember they were never supposed to be pinned down to a single path, rewinding the clock to restore their original fuzzy quantum state. This isn't just a parlor trick with tiny particles. It suggests something far more profound. The present can reach back and change the past. Think about what that means for our understanding of time. We're used to thinking of cause and effect as a one-way street, first the cause, then the effect. But the quantum eraser hints that at the most fundamental level, the universe doesn't play by those rules. Future choices like whether to erase measurement data can seemingly influence events that already happened. It's as if reality stays in a state of quantum limbo, refusing to fully commit to a version of events until all possible observations are accounted for. Now you might be asking, how is this even possible? One way to wrap your head around it is to think of reality as a cosmic choose-your-own-adventure book where the story isn't fixed until you flip to the last page. Until then, every possible path exists in superposition. The quantum eraser shows us that some of those paths can be erased or rewritten, even after they seem to have already been chosen. This doesn't mean we can go back and change major historical events. These effects are subtle, playing out at the scale of individual particles, but the philosophical implications are enormous. If observation can retroactively alter the past, then what we call reality might be far more malleable than we ever dared to imagine. The experiment also forces us to confront a thorny question. What counts as an observation? Does it require a conscious observer, or is any interaction between particles enough to collapse the quantum possibilities? Some interpretations suggest that the universe doesn't need humans to look at anything. It's the act of information becoming irreversible that locks in reality. Others argue that consciousness might play a more active role in shaping the cosmos. Either way, the quantum eraser blurs the line between the observer and the observed, leaving us with a universe that feels less like a clockwork machine and more like an ongoing conversation between possibility and perception. Perhaps the most startling takeaway is this: the past might not be as set in stone as we think. The quantum eraser experiment doesn't just challenge our understanding of physics, it shakes the foundations of how we experience time itself. If reality remains unsettled until the last possible moment, then the universe isn't just stranger than we imagine, it's stranger than we can imagine. And that's what makes this one of the most thrilling frontiers of science, a place where the rules we take for granted dissolve, and the true nature of existence reveals itself to be far more mysterious than we ever dreamed. Let's break down the quantum eraser experiment step by step to see just how bizarre the universe really is. First, a single photon is sent toward a double-slit barrier, just like in the classic setup. But here's where things take a sharp turn into the unknown. Before the photon reaches the detector, scientists use a special device, often a beam splitter or a polarizing filter, to mark which slit it passed through. This which path information is stored like a tag on the photon's journey. At this point, the photon behaves like a particle, leaving no interference pattern, as if it knew its path was being recorded. Now here's the magic trick. After the photon has already hit the detector, the experimenters have a choice. They can either keep that path information or erase it. If they erase it by scrambling the markers so it's impossible to tell which slit the photon took, something incredible happens. The interference pattern, that hallmark of wave-like behavior, suddenly reappears on the screen. It's as if the photon retroactively decides to act like it was never observed in the first place. The past isn't just set in stone, it's more like wet clay reshaped by what we choose to do in the present. This delayed choice phenomenon turns our understanding of time on its head. Normally, we assume that causes come before effects, that the past influences the future. But the quantum eraser suggests the opposite might also be true. Future decisions can ripple backward, altering what seemed like settled history. Imagine throwing a ball and then, after it's already landed, choosing whether it should have traveled in a straight line or curved through the air. That's the level of absurdity we're dealing with here. What makes this even stranger is that the photon's behavior doesn't just change, it changes based on a choice that hasn't happened yet. The decision to erase or preserve the path information isn't made until after the photon has technically finished its journey. And yet, that late decision determines whether the photon acted like a particle or a wave all along. This isn't just a quirk of measurement, it's a fundamental challenge to the idea that time flows in one direction, or that events have a single, objective history. So what's really going on? One interpretation is that reality remains in a state of quantum uncertainty until all possible information is accounted for. The photon doesn't commit to a single version of events until the experimenters make their final choice. It's like the universe is holding its breath, waiting to see how the story ends before deciding how it began. Another mind-bending possibility is that time itself might be an illusion at the quantum level, with past, present, and future existing in a tangled web where cause and effect aren't so neatly separated. The implications of this experiment stretch far beyond the lab. If the present can influence the past, even in such a subtle way, it forces us to rethink not just physics, but the nature of reality itself. Are we living in a universe where the future is just as real as the past, where observation doesn't just record history but actively shapes it? The quantum eraser doesn't give us easy answers, but it does give us a glimpse into a cosmos far stranger, far more dynamic than we ever imagined. And that's what makes it one of the most thrilling puzzles in all of science. Quantum entanglement isn't just a side note in the quantum eraser experiment. It's the secret ingredient that makes the whole thing work. Picture two photons born together in a quantum embrace, their fates intertwined no matter how far apart they travel. Change one, and the other instantly responds, as if they're sharing a hidden language that bypasses space and time. Einstein famously called this spooky action at a distance, and it's this very phenomenon that allows the quantum eraser to pull off its greatest trick, rewriting history. Here's how it unfolds in the lab. Scientists create pairs of entangled photons and send them on separate journeys. One photon heads toward the double slits, while its partner is diverted to a detector. The magic happens when researchers decide to measure or erase the which path information of the second photon. Astonishingly, this choice doesn't just affect the photon they're tinkering with. It reaches back in time to alter the behavior of its entangled twin, the one that already passed through the slits. If the path information is erased, the first photon suddenly remembers it was part of a wave, and the interference pattern springs back to life. It's as if the universe is performing a synchronized dance, with particles millions of miles apart moving in perfect, instantaneous harmony. This isn't just a curiosity, it's a radical challenge to how we think about reality. Entanglement suggests that the universe isn't a collection of isolated objects, but a vast, interconnected web where everything is subtly in touch with everything else. The quantum eraser takes this idea further, showing that observation isn't just a passive act of seeing. It's an active force weaving particles together into a shared story. When we choose to erase information, we're not just cleaning up data, we're unraveling a thread in the fabric of reality itself, allowing entangled particles to revert to their original, unobserved state. The implications are staggering. If entangled particles can influence each other across vast distances, what does that say about the nature of space? Could the universe be fundamentally non-local, with everything secretly connected beneath the surface? And if observation binds particles together, does that mean consciousness, or at least interaction, plays some role in stitching reality into existence? These questions push us toward the edge of known physics, where the boundaries between science and philosophy blur. One thing is certain: entanglement forces us to abandon the cozy, clockwork universe of classical physics. In the quantum realm, particles don't just interact, they share a deeper, invisible kinship that defies our everyday intuition. The quantum eraser doesn't just reveal this connection, it lets us tug on the threads, showing how delicate and malleable reality truly is. And that leaves us with a haunting possibility. Perhaps the universe isn't something we observe. Perhaps it's something we participate in, moment by moment, choice by choice, in ways we're only beginning to understand. The observer effect and the quantum eraser might sound like two sides of the same coin, but they reveal fundamentally different truths about reality. The classic observer effect tells us that measuring a quantum system inevitably disturbs it, like trying to measure the temperature of a drop of water with a thermometer so large it absorbs all the heat. This is straightforward enough. Tools interact with what they measure, but the quantum eraser takes this idea and turns it inside out. It shows that the disturbance caused by observation isn't necessarily permanent. Like a cosmic undo button, erasing the which path information can restore the system to its original, unobserved state, complete with its wave-like interference patterns. This distinction isn't just academic, it reshapes how we think about the nature of reality itself. The observer effect suggests that measurement forces the universe to pick a path, while the quantum eraser reveals that the universe might keep its options open until the very last moment. Imagine a detective piecing together a crime scene. The observer effect is like taking a photo of a suspect. Once the picture is snapped, the moment is frozen. But the quantum eraser is like realizing the photo can still be edited, blurring the suspect's face so thoroughly it's as if the original snapshot never happened. The past isn't just changeable, it's unresolved until every possible observation is settled. This raises a dizzying question: does the universe need observers to finalize reality? Some interpretations suggest that quantum systems remain in a state of superposition, multiple possibilities existing at once, until an irreversible record is made. It's not about human consciousness per se, but about whether information becomes locked in to the universe's ledger. Others take it further, proposing that conscious observation might play an active role in collapsing these possibilities. Either way, the quantum eraser hints that reality isn't a fixed timeline but a fluid network of potentialities, where the future can retroactively tweak the past. And then there's the elephant in the room: free will. If the universe delays choosing a definite state until all observations are in, does that mean our decisions somehow influence events that already occurred? The quantum eraser doesn't give us a clear answer, but it forces us to confront the possibility that causality might be more flexible than we ever imagined. It's as if the universe is a grand puzzle, withholding its final shape until every piece, every observation, every choice is placed. Whether that's a comforting thought or a terrifying one depends on how much uncertainty you're willing to embrace. What's certain is this: the quantum eraser doesn't just challenge our understanding of physics, It forces us to rethink what it means to exist in a universe where reality might be less like a finished painting and more like a sketch, waiting for the final strokes of observation to bring it into focus. And that's a mystery far stranger and far more thrilling than anything classical physics ever dreamed of. The idea that the future could reach back and tweak the past isn't just science fiction, it's a genuine possibility in the quantum realm. When the quantum eraser experiment shows interference patterns reappearing after we delete measurement data, it's as if particles are rewriting their own history based on choices we haven't made yet. This isn't just a glitch in the system, it's a window into retro-causality where cause and effect don't follow the neat, linear timeline we're used to. Imagine dropping a pebble into a pond and watching the ripples flow backward toward your hand. That's the level of temporal weirdness we're dealing with here. But how could this possibly work? One radical explanation comes from the block universe theory, which suggests that time isn't a flowing river but a frozen landscape where past, present, and future all exist simultaneously. Think of it like a DVD. Every moment is already there, encoded on the disc, and our consciousness is just the laser moving from scene to scene. In this view, the quantum eraser doesn't change the past so much as reveal that the past was never fixed to begin with. Observation becomes less about recording reality and more about selecting which slice of the block universe we experience. It's as if the universe holds every possible version of events in superposition until an observer locks one into place, and even then, that lock can be undone. This challenges one of our deepest assumptions that the past is immutable. We're used to thinking of history as a series of unalterable facts, but quantum mechanics paints a far more fluid picture. If erasing information today can alter how a particle behaved yesterday, then what we call the past might be more like a draft, subject to revisions until the final edit is made. This doesn't mean you can go back and prevent your childhood mishaps. These effects are subtle, confined to the quantum scale, but philosophically it's explosive. It hints that time itself might be an emergent property, something that arises from the way we interact with the universe rather than a fundamental feature of it. The implications ripple outward. If retro-causality is real, even in this limited sense, it blurs the line between memory and prediction. Normally, we remember the past and anticipate the future, but the quantum eraser suggests these two directions might be entangled in ways we can't yet fathom. Some interpretations even propose that consciousness itself could be the glue that binds these moments together, stitching the block universe into a coherent narrative. Others argue it's simply the universe's way of keeping its options open until the last possible second. Either way, the quantum eraser forces us to confront a breathtaking possibility. The arrow of time might not point in just one direction after all. And that leaves us with a humbling thought. If the past isn't set in stone, then reality might be far more collaborative than we ever imagined. We're not just passive observers of a pre-written cosmic story, we're active participants, shaping the tale as it unfolds with every measurement, every choice, and even every act of erasure. The quantum eraser doesn't just reveal the strangeness of the universe, it invites us to reconsider our place within it as co-authors of a reality still being written. If observation truly shapes reality, then the universe we know might not just exist independently, it could be a cosmic canvas waiting for the brushstrokes of awareness. This radical idea, known as the participatory universe theory, flips the traditional script of physics on its head. Instead of consciousness emerging from the machinery of the brain, it proposes that consciousness is woven into the fabric of reality itself, a silent architect shaping the universe from the quantum foam up. Think of it like a grand symphony where the notes only become music when someone listens. Without an observer, the cosmos might remain a cacophony of possibilities, never settling into the orderly universe we recognize. This isn't just philosophical speculation. The quantum eraser experiment hints that particles don't choose their state until measured. Extend that logic to the scale of galaxies, and you're left with a staggering question. Could the entire universe exist in a superposition of potentialities until some form of observation locks it into place? Some interpretations of quantum mechanics, like the von Neumann-Wigner hypothesis, take this even further, suggesting that consciousness itself might be the trigger that collapses these cosmic probabilities into reality. It's as if the universe is a story that only becomes real when someone reads it. But who or what counts as an observer in this grand scheme? Does it require human minds, or could any interaction between particles serve as a kind of rudimentary observation? If even a single photon bouncing off a distant star qualifies, then the universe might be a self-observing system, constantly solidifying its own existence through countless tiny interactions. On the other hand, if consciousness is uniquely capable of collapsing quantum states, then the cosmos becomes something far more intimate, a shared hallucination, shaped by every living being that perceives it. The implications ripple outward, touching everything from the nature of time to the fate of the cosmos. If reality depends on observation, what happens in the vast voids between galaxies where no conscious beings might exist? Does the universe there remain in a hazy, undefined state? And what about before life emerged? Was the early cosmos a ghostly realm of potential, waiting billions of years for the first conscious observers to bring it into focus? These questions straddle the line between physics and metaphysics, forcing us to confront the possibility that the universe isn't just stranger than we imagine, it might be stranger than we can imagine. At its heart, the participatory universe theory blurs the boundary between the observer and the observed, suggesting that we're not just passive witnesses to reality, but active participants in its creation. It's a humbling, even poetic thought that the very act of looking at the stars might, in some small way, help them shine. Whether this idea holds up under the weight of further experimentation remains to be seen. But one thing is certain: the quantum eraser has flung open a door to a universe far more mysterious, far more interconnected than we ever dared to dream. And behind that door lies a truth that could redefine not just physics, but our place in the cosmos itself. The question of whether consciousness plays a starring role in shaping reality isn't just a fringe idea, it's a debate that cuts to the core of quantum mechanics. On one side, you have interpretations like von Neumann and Wigner's, which suggest that human observation isn't just a passive recording of events, but an active force that collapses the quantum wave function, turning a haze of possibilities into concrete reality. Picture a tree falling in a forest with no one around. Does it make a sound? In this view, the question becomes even more profound. Does the tree even exist in a definite state until someone observes it? It's a staggering thought that the universe might remain in a kind of quantum limbo, waiting for conscious minds to bring it into focus, but not everyone agrees. The opposing camp argues that any interaction, whether it's a human eye, a photon hitting a detector, or even a stray atom bumping into another, counts as an observation that collapses the wave function. In this scenario, consciousness isn't special. It's just one of many players in a universe that's constantly observing itself. Think of it like a vast cosmic game of telephone, where every particle interaction passes along information, locking reality into place bit by bit. This interpretation keeps the universe running without relying on human minds, which might be more comforting for those who prefer their physics free of metaphysical baggage. The debate isn't just about physics, it's a philosophical battleground. If consciousness is required to fix reality, then mind and matter might not be separate at all. Instead, they could be two sides of the same coin, with perception shaping the very fabric of existence. This idea echoes ancient philosophies and spiritual traditions that see consciousness as foundational to the cosmos. On the other hand, if any interaction can collapse the wave function, then the universe operates like a self-sufficient machine, humming along whether we're here to witness it or not. Here's where things get even more intriguing. Some experiments hint that conscious observation might have a unique effect. In studies where human participants are asked to focus on quantum systems, slight but statistically significant deviations from expected results have been recorded. Skeptics dismiss these as anomalies, but proponents argue they're glimpses of a deeper truth, that the mind doesn't just perceive reality, but participates in its creation. It's as if the universe is a collaborative artwork, and consciousness is the brush that gives it form. Yet, the mystery remains unsolved. Whether consciousness is a cosmic architect or just another bystander in a self-organizing universe, one thing is clear: the quantum world refuses to play by the rules we're used to. It's a realm where observation and existence are tangled in ways that defy intuition, leaving us to wonder if reality is truly out there, or if, in some strange and beautiful way, we're all co-creators of the world we perceive. If every choice we make spawns an entirely new universe, then the quantum eraser experiment isn't just revealing the flexibility of reality. It might be showing us a glimpse of the multiverse in action. Picture this: every time a particle faces a quantum decision like which slit to pass through, it doesn't just pick one path. Instead, the universe splits, creating parallel timelines where every possible outcome plays out. In one reality, the particle goes left. In another, it goes right. And when we erase the which path information, we're not just rewinding a single timeline. We might be momentarily bridging these branching worlds, allowing interference patterns to reappear as if the universe is whispering, "All these possibilities still exist, you're just seeing one slice of them." This idea, known as the many worlds interpretation, takes the weirdness of quantum mechanics and scales it up to cosmic proportions. It suggests that the quantum eraser isn't just about particles changing their past, it's about us peeking behind the curtain of a much grander multiverse. Think of it like a library where every book tells a slightly different version of history. Normally, we only get to read one at a time, but the quantum eraser lets us catch a fleeting glimpse of the other stories, as if the pages are momentarily transparent, revealing the overlapping narratives beneath. Here's where it gets even wilder. If the multiverse is real, then every possible outcome of every quantum event is playing out somewhere. That means there's a version of you who made different choices, a version of Earth where history unfolded another way, even universes where the laws of physics themselves are unrecognizable. The quantum eraser experiment could be a rare moment when these parallel realities briefly interfere with one another, like radio stations bleeding into each other's signals. The interference pattern on the detector screen wouldn't just be a quirk of waves and particles, it might be the signature of countless universes brushing against ours, their possibilities momentarily visible before they fade back into the cosmic static. But how does observation fit into this? If the multiverse is teeming with infinite versions of reality, why do we only experience one? The answer might lie in the strange relationship between quantum mechanics and consciousness. Some theories propose that our observations don't just collapse possibilities into a single reality, they select which branch of the multiverse we inhabit. It's as if every time you make a choice, you're not erasing the other options. You're just stepping onto a different path in an ever-growing labyrinth of existence. The quantum eraser, then, becomes a tool that lets us momentarily straddle those paths, revealing the threads that connect them. Of course, not everyone agrees. Critics argue that the multiverse is an elegant way to dodge the weirdness of quantum observation, a cosmic out that replaces one mystery with another. After all, if every possibility happens somewhere, then there's no need to explain why particles behave differently when observed. They're just doing all possible things in all possible worlds. But this raises its own questions. If there are infinite versions of reality, how do we explain the eerie consistency of the universe we see? And why does it feel like we're the ones making choices, rather than passively inhabiting one thread in an infinite tapestry? The multiverse interpretation doesn't just challenge our understanding of physics, it reshapes how we think about identity, free will, and even the nature of existence itself. Are we single, isolated observers, or just one version of a consciousness spread across countless realities? The quantum eraser doesn't give us definitive answers, but it offers something just as valuable. A tantalizing hint that the universe might be vaster, stranger, and more interconnected than we ever imagined. And that's a thought worth sitting with, whether you're in this universe or the next one over. What if the quantum eraser isn't just a lab curiosity, but a cosmic phenomenon playing out on the grandest scales imaginable? Imagine two particles born together in the heart of a dying star, then flung to opposite ends of the universe, still entangled, still whispering to each other across billions of light years. Now imagine those particles behaving like the ones in our quantum eraser experiments, their fates intertwined in ways that defy the speed of light and the very fabric of space-time. This isn't science fiction. It's a real possibility that could rewrite our understanding of the cosmos. Take black holes, for instance. These cosmic monsters don't just warp space, they might be natural quantum erasers on a galactic scale. When matter falls into a black hole, it doesn't just vanish. According to quantum theory, information can't be destroyed, so something must happen to preserve it. One wild idea is that black holes store this information in their event horizons, effectively erasing and re-encoding it in a way that mirrors the quantum eraser's ability to undo observations. If that's true, then the universe might be performing its own version of the experiment, with black holes acting as cosmic editors, selectively revealing or hiding quantum information across the ages. But the implications go even further. If entangled particles can influence each other instantly, no matter how far apart they are, then the universe might be fundamentally non-local. That means two events could be connected without any physical signal traveling between them, as if the cosmos is threaded with invisible strands that bypass space and time entirely. Picture a pair of dice rolled on opposite sides of the galaxy. If they're quantum entangled, landing on 6 here might instantly guarantee a 6 over there, with no delay, no communication, just a mysterious synchronicity that Einstein himself called spooky. This challenges one of physics' most cherished principles, locality, the idea that objects are only influenced by their immediate surroundings. If quantum eraser-like behavior exists on cosmic scales, then locality might be an illusion, a quirk of our limited perception. Instead, the universe could be more like a hologram, where every part contains information about the whole, and what happens in one corner instantly ripples through the entire system. It's as if the cosmos is a single, interconnected quantum network, with galaxies, stars, and even you and me as nodes in a vast, pulsating web of possibility. And here's the kicker: if the universe is this deeply interconnected, then observation might not just shape reality in a lab, it could shape reality everywhere. A conscious observer on Earth could, in theory, influence the state of a particle near a distant quasar, not by sending a signal, but simply by looking. This isn't about magic or mysticism. It's about the universe operating by rules we're only beginning to glimpse. Whether it's black holes editing quantum information or entangled stars dancing in lockstep, the quantum eraser might be more than an experiment. It could be a key to unlocking the universe's deepest secrets. So the next time you gaze up at the night sky, remember, those twinkling stars might not just be distant suns. They could be part of a cosmic quantum eraser, flickering in and out of definite existence, their stories still unwritten, waiting perhaps for an observer to bring them into focus. And that's a thought as humbling as it is thrilling. Modern quantum eraser experiments have evolved far beyond their original setups, using cutting-edge technology to probe the edges of reality itself. Scientists now employ ultra-sensitive photon detectors, precision lasers, and intricate arrangements of beam splitters that would make even the most seasoned physicist's head spin. In one groundbreaking study, researchers separated entangled photons by over 1,200 kilometers, a distance so vast it would take a commercial jet 2 hours to cover, and still observed the same eerie synchronization. When they erased the which path information of one photon, its entangled partner instantly responded, as if no space or time separated them at all. This isn't just a quirk of carefully controlled lab conditions. It's a fundamental feature of the universe, playing out on scales that dwarf our everyday experience. What makes these modern experiments so remarkable isn't just their technical sophistication, but what they reveal about the nature of reality. Early skeptics dismissed quantum weirdness as a byproduct of imperfect equipment or environmental noise. But today's setups are isolated from vibrations, shielded from electromagnetic interference, and chilled to near absolute zero to eliminate even the faintest disturbances. And yet, the quantum eraser effect persists undiminished. It's as if the universe is insisting, this isn't a bug in your experiments, it's how things really work. When you can send photons through fiber optic cables spanning continents and still see interference patterns reappear upon erasure, you're not just testing physics, you're stress testing the very framework of cause and effect. Perhaps the most astonishing twist is how these experiments bridge the gap between the microscopic and the cosmic. Quantum mechanics once seemed confined to the realm of atoms and particles, irrelevant to the larger world we inhabit. But now we're seeing quantum effects persist over distances comparable to those between cities, even between satellites in orbit. This blurring of scales suggests that the quantum eraser isn't just a curious footnote in physics textbooks. It might be a clue to how the universe stitches itself together at every level. Imagine a tapestry where the threads connect not just adjacent points, but leap across the entire fabric, linking distant corners in ways that defy conventional logic. Yet for all their precision, these experiments raise as many questions as they answer. If quantum entanglement holds over vast distances, what does that imply about the nature of space itself? Could the universe be fundamentally interconnected in ways we're only beginning to glimpse? And if observation can undo quantum events retroactively, even across thousands of kilometers, what does that say about the flow of time? Each new experiment peels back another layer, revealing a cosmos far stranger, far more dynamic than the static, clockwork universe we once imagined. The takeaway is clear: quantum weirdness isn't going away. As our tools grow sharper and our experiments more ambitious, the quantum eraser continues to challenge our deepest assumptions about reality. It's not just a puzzle to solve, it's a window into a universe where the ordinary rules don't apply, where observation shapes existence, and where the past might just be waiting for the future to make up its mind. And that's a revelation that's only getting harder to ignore. Not everyone is ready to embrace the quantum eraser's mind-bending implications. For every physicist who sees it as evidence of retro-causality or conscious observation shaping reality, there's another who insists the experiment is being wildly misinterpreted. Take the wave mechanics purists, for example. They argue that the reappearing interference pattern isn't some mystical undo button for reality. It's just the natural behavior of waves when you remove which path information. Think of it like listening to two overlapping songs. If you mute one track, the other becomes clearer. That's not time bending backward. It's basic wave physics playing out exactly as expected. Then there's the camp that rejects the idea of observation having any special role at all. Hidden variable theories suggest particles might carry unseen properties that dictate their behavior from the start, like invisible train tracks guiding them to their destinations. No need for consciousness or collapsing wave functions, just physics we haven't discovered yet. Pilot wave theory takes this even further, proposing that particles are pushed along by unseen pilot waves, giving the illusion of randomness while actually following deterministic rules. It's a comforting thought, a universe that's strange but not that strange, but here's the catch. These alternatives come with their own baggage. Hidden variables would need to operate faster than light to explain entanglement, violating relativity's speed limit. Pilot waves, while elegant, struggle to scale up to the complexity of the quantum world we observe, and wave mechanics alone can't easily explain why the act of measurement changes the system so profoundly. The debate isn't just academic nitpicking, it's a battle over how fundamentally weird we're willing to let reality be. What's fascinating is how these disagreements reveal quantum mechanics' greatest open secret. It works flawlessly in practice, but no one fully agrees on why. The math predicts outcomes with jaw-dropping precision, yet the underlying mechanics remain a philosophical minefield. Even giants like Einstein and Bohr famously clashed over whether the moon exists when no one's looking. Today's quantum eraser debate is just the latest chapter in that century-old struggle, a reminder that the universe's deepest truths might still be hiding in plain sight. So where does that leave us? In a way, the lack of consensus is the most exciting part. It means the quantum eraser isn't just a solved puzzle, it's an invitation. Whether you side with the mystics, the mechanics, or the pragmatists, one thing's certain. This experiment has cracked open a door to a universe far stranger than any of us imagined. And the best part, we're all still figuring out what's on the other side. The quantum eraser doesn't just tinker with particles, it shakes the foundations of how we perceive reality itself. At its core, this experiment forces us to ask, is the universe a fixed objective stage, or is it something far more fluid, shaped by the act of observation? Philosophers have wrestled with this question for centuries, but quantum mechanics drags it from the realm of abstract thought into the lab. If a particle's past can be rewritten by future choices, then what we call reality might be less like a stone sculpture and more like wet clay, constantly reshaped by the hands of perception. Take the notion of free will. If the past isn't truly settled until observations lock it in, does that mean our choices ripple backward as well as forward? Imagine deciding to erase a measurement, and in doing so, altering how a particle behaved moments ago. It's as if the universe is a canvas where the artist keeps painting over earlier strokes, never quite committing to a final version. This doesn't just challenge our idea of cause and effect, it blurs the line between the chooser and the chosen. Are we making decisions, or are we just catching up to a story that's still being written? Then there's the enigma of time. We experience it as an arrow flying inexorably from past to future. but the quantum eraser suggests time might be more like a river with eddies and currents that loop back on themselves. If erasing information today can change what seemed like a settled past, then time itself might be an illusion, a convenient fiction our brains construct to make sense of a cosmos that operates outside linearity. Think of it like reading a novel where the ending rewrites the opening chapters, except in this case, the novel is the universe and we're both the readers and the authors. And what of space? Quantum entanglement shows particles influencing each other instantaneously across vast distances, as if space is just a stage set, not the fundamental fabric we thought it was. If observation can connect events faster than light, then the universe might be more like a hologram where every part contains the whole, and separateness is just a trick of perspective. It's a vision that echoes ancient philosophies and cutting-edge physics alike, a reminder that the deepest truths often defy the boundaries we try to impose. The quantum eraser doesn't just belong to physicists, it's a mirror held up to the human condition, reflecting our eternal struggle to understand our place in the cosmos. Are we passive witnesses to an objective world or active participants in a reality that bends to meet our gaze? The answer, it seems, might be both and neither. One thing is certain, the universe is far stranger, far more wondrous than our ancestors ever dreamed, and the most thrilling part, we're only just beginning to glimpse its true nature. The quantum eraser doesn't just bend the rules of cause and effect, it twists them into knots, suggesting that time itself might be more malleable than we ever dared to imagine. If erasing observation data can retroactively alter a particle's behavior, then information isn't just flowing forward, it's looping backward, like a river doubling back on itself. This isn't science fiction's version of time travel with DeLoreans and paradoxes. It's subtler, stranger, and far more profound. The universe might allow tiny fragments of the future to reach into the past, not by breaking physical laws, but by revealing that those laws were never as rigid as we thought. Consider what this could mean for communication. Imagine a quantum network where entangled particles act as messengers, not just across space but across time. A decision made today could, in theory, influence the state of a particle yesterday, encoding information in a way that defies classical timelines. It's not quite sending a text to your past self, but it's a glimpse into a world where the arrow of time isn't one way. Think of it like leaving a note in a drawer, only to realize the note was already there before you decided to write it. Disorienting, absolutely. But it's precisely this kind of weirdness that could revolutionize quantum computing, where operations might one day exploit retro-causality to solve problems faster than light-speed logic would allow. The implications for history itself are even more startling. If the quantum eraser shows that observation can rewrite the past, even on a microscopic scale, it challenges the very idea of history as a fixed record. Instead, the past might be more like a draft, with certain details remaining negotiable until all observations are settled. Picture an ancient light particle from a distant star, its journey through the cosmos unresolved until a scientist on Earth finally measures it. In that moment, the particle's entire history, stretching back millions of years, snaps into focus. It's as if the universe hesitates to commit to a story until the last possible witness has their say. This doesn't mean we can rewrite major historical events. Quantum effects are delicate, easily drowned out by the noise of the macroscopic world. But it does suggest that at the most fundamental level, time might not flow in the linear, one-directional way we experience. Instead, the universe could be a vast, interconnected web where past, present, and future exist in a kind of dynamic equilibrium, constantly adjusting to accommodate new observations. It's a vision that aligns with some interpretations of quantum gravity, where time emerges from deeper, timeless laws like a movie projected frame by frame, even though the entire reel exists at once. Of course, the big question remains, if information can trickle backward, could we ever harness this for practical time travel? The answer, for now, is a cautious no, at least not in the way pop culture envisions. The quantum eraser's retro-causality operates on the level of individual particles, not people or objects, but it's a tantalizing hint that the universe might not forbid time loops entirely. Some physicists speculate that advanced civilizations could one day build quantum time mirrors, devices that exploit entanglement to send signals into the past. Others argue that even if such feats are possible, they'd be inherently limited, like trying to sculpt a mountain with a toothpick. Yet the mere possibility is enough to rewrite our understanding of reality. If the past isn't set in stone, if it remains fluid until observed, then the universe is far more dynamic, far more participatory than we ever imagined. It's not just that time travel might be possible in some exotic form. It's that time itself might be an illusion, a side effect of how we perceive a cosmos where every observation is a stitch in the fabric of existence. And that's a revelation that doesn't just belong to physicists. It's an invitation to rethink what it means to exist in a universe where the past, present, and future might all be happening at once. The quantum eraser isn't just a mind-bending thought experiment, it's a gateway to revolutionary technologies, particularly in the world of quantum computing. At the heart of quantum computers lies the same bizarre behavior we see in the eraser experiment. Particles existing in multiple states at once, entangled across distances, and collapsing into definite realities only when observed. These machines don't process information with simple zeros and ones like classical computers. Instead, they use qubits which can be 0, 1, or both simultaneously, thanks to superposition. But here's the catch. Just like in the quantum eraser, the act of measuring these qubits forces them to choose a state, potentially disrupting calculations. That's where the eraser's insights become invaluable. By understanding how observation shapes reality, scientists are developing ways to peek at quantum data without fully collapsing it, like reading a book without turning the pages. One of the most promising applications lies in quantum error correction. In conventional computing, errors are easy to spot and fix, but in the quantum realm, any attempt to check for mistakes can accidentally alter the data itself. Imagine trying to count bubbles in a glass of soda. The moment you touch one, it pops. Quantum eraser-inspired techniques could let us glance at qubits indirectly, using entangled particles to infer information without direct observation. This could mean the difference between a quantum computer that's hopelessly fragile and one that's robust enough to solve problems like simulating complex molecules for life-saving drugs or optimizing global supply chains in seconds. Then there's the game-changing potential for unbreakable encryption. Quantum communication systems already use entangled particles to create cryptographic keys that are inherently secure. Any attempt to eavesdrop would disturb the system, alerting the users instantly. But the quantum eraser takes this further. By deliberately erasing or retaining observation data, we could create self-correcting networks where information is only decrypted at the precise moment it's needed, leaving no trace for hackers to exploit. Picture a vault that only materializes when the right person looks at it, then vanishes without a trace, but the most tantalizing possibilities lie just beyond the horizon. If we can master the delicate interplay between observation and quantum states, we might unlock technologies that sound like pure science fiction today. Imagine sensors so precise they can detect gravitational waves from distant supernova by spotting ripples in entangled particles, or quantum AI that evolves its own algorithms in superposition before delivering flawless solutions. The quantum eraser doesn't just hint at these futures, it hands us the tools to build them. Every time we learn to manipulate how observation shapes reality, we're not just understanding the universe. We're learning to rewrite its rules. Einstein's theory of relativity and the bizarre rules of quantum mechanics have long been locked in a cosmic tug of war, each refusing to surrender its vision of how the universe works. Relativity insists nothing can outpace light, a universal speed limit etched into the fabric of space-time. Yet the quantum eraser shows entangled particles coordinating instantly across vast distances, as if they're thumbing their noses at Einstein's careful equations. This isn't just a minor disagreement, it's a fundamental clash between two pillars of physics, and resolving it could rewrite our understanding of reality itself. At first glance, the conflict seems irreconcilable. Imagine two entangled photons, one on Earth and the other near a distant star. When we erase the which path information of one, its partner instantly responds as if no space separates them. Relativity argues this influence would need to travel faster than light, violating cosmic law. But here's the twist: no actual information is being transmitted. It's more like flipping a coin in New York and another in Tokyo. Both always land the same way, not because of communication, but because their outcomes were linked from the start. This subtle distinction keeps quantum weirdness from outright breaking relativity, but the tension remains. The universe seems to be playing by two sets of rules, and physicists are desperate to find the hidden referee. Some theorists propose that entanglement doesn't defy relativity because it operates outside space-time altogether. Picture a pair of dancers in separate rooms, moving in perfect sync, not because they're signaling each other, but because they're following the same invisible choreography. In this view, entangled particles aren't communicating, they're simply two parts of a single quantum system, their connection woven into the deeper structure of reality. This idea, called quantum non-locality, suggests that what we perceive as vast distances might be illusions, with the universe fundamentally interconnected in ways we can't yet measure. Others see the quantum eraser as a clue to a grander theory waiting to be discovered. Just as Einstein unified space and time with relativity, physicists dream of a framework that reconciles quantum mechanics with gravity, a theory of everything. The eraser's retro-causality hints that time might not be the one-way street relativity assumes. Could space-time itself emerge from quantum interactions, like waves rising from a deeper ocean? Some models suggest that what we call instantaneous entanglement is actually a ripple in a higher dimensional geometry, where space and time are secondary to quantum relationships. The stakes couldn't be higher. If we can untangle this knot, we might finally understand black holes, where quantum and relativistic effects collide violently. Or crack the mystery of dark energy, which stretches the cosmos while quantum particles buzz in the void. Even time itself might be up for redefinition, not as a universal constant, but as a collective illusion born from quantum observation. The quantum eraser isn't just a lab curiosity. It's a torch in the dark, guiding us toward a physics that embraces both the certainty of relativity and the fluidity of the quantum world. And that journey could lead us to the most profound discovery of all, a universe far more unified, far more elegant than we ever dared to dream. Could the human brain itself be a quantum eraser, subtly shaping reality at the deepest level? This isn't just wild speculation, it's the cutting edge of quantum biology, where scientists are uncovering startling hints that living systems might harness quantum weirdness to function. Take photosynthesis, for example. Plants convert sunlight into energy with near-perfect efficiency, a feat classical physics struggles to explain. But when researchers probed deeper, they found evidence of quantum coherence, the same phenomenon that lets particles exist in multiple states at once, operating inside chlorophyll molecules. It's as if nature stumbled upon quantum tricks billions of years before humans even discovered them. Now, zoom into the human brain. Your neurons communicate via electrical impulses, but the real magic might happen at the nanoscale, inside structures called microtubules. These tiny protein filaments could be hosting quantum vibrations, creating a symphony of superposition and entanglement right inside your skull. Nobel laureate Roger Penrose and anesthesiologist Stuart Hameroff proposed that these quantum processes might even give rise to consciousness itself. In their theory, dubbed ORCH or collapsing quantum states in microtubules generate moments of awareness, like pixels flickering into the image of a mind. If true, this would mean your thoughts aren't just chemical reactions, they're quantum dances, with every decision potentially influenced by the same probabilistic rules that govern particles in the eraser experiment. The implications are staggering. Intuition, those gut feelings we can't quite explain, might emerge from quantum computations happening beneath conscious awareness. Imagine your brain as a quantum computer, processing probabilities in parallel before delivering a eureka moment. Even creativity could stem from this hidden quantum layer, with the brain exploring countless possibilities in superposition before collapsing into a single brilliant idea. And what about free will? If quantum randomness plays a role in neural processes, it might provide the wiggle room needed for genuine choice, a middle ground between determinism and chaos. But the real showstopper is how this ties back to the quantum eraser. If consciousness arises from quantum interactions, then observing the world might not just record reality, it could actively participate in its creation. Your brain, with its potential quantum infrastructure, wouldn't just be a passive receiver of information. It might be a collaborator, subtly shaping the universe's unfolding story through the act of perception. This isn't just philosophy, it's testable science. Experiments are already underway to detect quantum vibrations in neurons, while others probe whether anesthetics that erase consciousness also disrupt quantum coherence in microtubules. Critics argue the brain is too warm and wet for delicate quantum states to survive, citing decoherence, the tendency for quantum effects to vanish in noisy environments. Yet nature seems to have found workarounds, like in bird navigation. Migratory birds use quantum entanglement in their eyes to see Earth's magnetic field, a compass unaffected by temperature or movement. If evolution cracked quantum biology in avian vision, why not in human cognition? The debate is far from settled, but the mere possibility rewrites what it means to be a thinking, feeling being in a quantum universe. Whether consciousness taps into quantum phenomena or not, one thing is clear: the boundary between observer and observed is blurrier than ever. The quantum eraser doesn't just belong to physicists, it might be playing out inside you right now, with every thought, every choice potentially rippling back through the fabric of reality. And that's a mystery worth exploring, not just for science, but for what it means to be alive in a cosmos that might be more aware, more interconnected than we ever imagined. Hollywood has always had a love affair with mind-bending science, but few concepts captivate filmmakers like the quantum eraser. Take Interstellar's Tesseract scene, a swirling, four-dimensional labyrinth where Cooper reaches across time to manipulate his daughter's past. While the movie trades lab coats for wormholes, that moment captures the essence of the quantum eraser, the haunting idea that observation might rewrite history. Christopher Nolan didn't need to name-drop quantum mechanics to channel its spirit. The film's emotional core hinges on that same blurring of cause and effect, where love and gravity somehow bend time itself. Then there's Devs, the chilling FX series where a tech cult builds a quantum computer so powerful it reveals the deterministic threads of fate until the protagonist, Lily, makes a choice that shouldn't be possible. Her defiance mirrors the quantum eraser's most provocative implication, that free will might not be an illusion but a force capable of redrawing reality's blueprint. The show's eerie, gold-hued simulations aren't far removed from the interference patterns in a lab. Both suggest a universe where every possibility exists until someone forces it to choose. Even The Matrix dances with these themes. When Neo stops bullets mid-air, he's not just bending physics, he's acting like an observer collapsing a quantum superposition. The Wachowskis never explicitly mention the eraser experiment, but their red pill revolution hinges on the same existential question. Is the world we perceive truly there, or does it crystallize only when we look? Sci-fi thrives on these metaphors because they tap into something primal, the fear that reality might be flimsier than we thought, and that our gaze holds more power than we realize. But here's where art diverges from science. Films like Primer or Arrival stretch quantum weirdness into time loops and alien linguistics, while real-world physics stays stubbornly grounded in math and measurement. The quantum eraser doesn't let you send messages to your past self or alter macroscopic events. Its magic is subtler, playing out in photon counts and statistical noise. Yet the emotional truth remains. These stories resonate because they mirror our deepest anxieties about agency and meaning. If a particle's past isn't fixed until observed, what does that say about our choices? Are we, like Lily in Devs, rewriting our histories with every decision? The irony is delicious. The same experiment that baffles physicists becomes a narrative playground for exploring fate, memory, and identity. Whether it's Dark's convoluted timelines or Everything Everywhere All at Once's multiverse madness, pop culture latches onto the quantum eraser not for its equations, but for its existential weight. These stories ask what scientists hesitate to. If reality is this fluid at the smallest scales, could the same rules somehow, someday apply to us? That tension between cold lab results and hot human drama is why the quantum eraser will keep haunting our screens long after the credits roll. If observation truly shapes reality, then every act of noticing isn't just passive, it's a kind of cosmic craftsmanship. This shifts science into the realm of ethics, where the question isn't just can we influence the universe, but should we? Imagine a world where every headline we click, every trend we amplify, doesn't just reflect reality but actively molds it. The quantum eraser hints that attention isn't neutral. It's a force that collapses possibilities into facts. So what happens when billions of human observers, each with biases, agendas, and blind spots, become unwitting architects of shared existence? Consider social media algorithms designed to feed us more of what we engage with. If collective focus literally solidifies certain versions of events, then viral misinformation isn't just distorting perceptions, it might be etching falsehoods into the fabric of reality itself. This isn't metaphor. Studies in quantum cognition suggest human decision-making mirrors quantum probabilities, with our choices influenced by superposition like states of uncertainty. If our minds operate on quantum principles, could the act of millions fixating on a conspiracy theory nudge the world toward making it true in some measurable way? The ethical stakes here are dizzying. It's one thing to curate your news feed. It's another to realize that curation might be curating reality. Philosophers have wrestled with observer responsibility for centuries, but quantum mechanics injects urgency into the debate. Indigenous cosmologies have long held that observation is participatory, that ceremonies and stories don't just describe the world but sustain it. Modern physics now echoes this wisdom. The double-slit experiment's collapse of wave functions mirrors ancient ideas that seeing breathes existence into things. If science and tradition converge here, dismissing this as coincidence feels reckless. Perhaps ethical observation means balancing skepticism with openness, rigor with reverence, a mindfulness that recognizes our gaze isn't just recording the universe, but in some small way, midwifing it. The climate crisis offers a sobering test case. If collapsing quantum possibilities requires energy, as some interpretations suggest, does humanity's relentless focus on consumption and growth lock us into a destructive trajectory? Conversely, could deliberate shifts in collective attention, like global movements prioritizing sustainability, literally bend reality toward greener possibilities? The quantum eraser's retro-causality hints that changing our observational habits today might ripple backward, softening the edges of past decisions. This isn't mystical thinking, it's the logical extension of entanglement's non-locality, where actions in the present resonate across time, yet the darkest implication lurks in the observer's blind spots. Quantum Darwinism proposes that only robust, frequently observed states survive decoherence to become real. If so, what happens to marginalized voices, to ecosystems too remote for mainstream attention? Ethical observation would demand intentional focus on the unseen, not just for justice, but because unobserved realities may remain unrealized. The act of witnessing becomes activism, not metaphorically but physically, like turning on lights in a room the universe forgot to furnish. This isn't about blaming individuals for not observing correctly. Reality shaping is distributed, messy, and poorly understood, but it does suggest that cultivating mindful attention in science, media, and daily life might be the most profound ethical act available to us. The quantum eraser doesn't just reveal how reality works. It whispers that we, as observers, hold a fragile responsibility to look wisely, to question compulsively, and perhaps to choose which versions of the world deserve to exist. Not everyone buys the idea that consciousness plays a starring role in quantum mechanics. For many physicists, the quantum eraser's strangeness can be explained without invoking minds or metaphysical leaps. They argue that observation in these experiments doesn't mean a human watching. It's any interaction that leaves a mark on the environment, like a photon hitting a detector or even just bumping into another particle. In this view, the universe doesn't need a conscious observer to snap possibilities into reality. It just needs something, anything, to disturb the system's delicate quantum dance. Take the double-slit experiment. When particles create an interference pattern, it's not because no one's looking. It's because their wave-like nature hasn't been disrupted by outside forces. The moment something interacts with them, whether it's a scientist's detector or a stray dust particle, that interference vanishes. The same logic applies to the quantum eraser. Erasing the which path information isn't about undoing a conscious act of seeing. It's about restoring the system's coherence by removing the physical disturbances that broke it in the first place. Think of it like smoothing out a crumpled piece of paper. The folds aren't memories of being handled, they're just physical changes that can be reversed. This more conservative interpretation keeps quantum weirdness firmly in the realm of physics, not philosophy. It sidesteps thorny questions about free will or the nature of consciousness by treating wave function collapse as a mechanical process, like a gear clicking into place. No need for cosmic observers or participatory universes, just particles obeying equations that happen to be counterintuitive. Even entanglement's spooky action at a distance fits this framework. The instantaneous connection between particles might feel mystical, but mathematically, it's just a feature of how quantum states evolve. No consciousness required. Yet this approach has its own puzzles. If observation is just interaction, why does the universe care whether information is preserved or erased? Why should particles behave differently based on whether their history could, in principle, be reconstructed? These questions hint that there's still something deeper at work, even if it's not consciousness. Some theorists propose that the key isn't minds but irreversibility, the moment quantum information becomes permanently recorded in the environment. Until then, the system stays fluid, like a sentence written in sand that waves can still wash away. The debate isn't just academic. It shapes how we interpret every quantum experiment, from the lab to the edges of the cosmos. If consciousness isn't special, then the universe hums along perfectly fine without us. But if our observations do play a unique role, then reality might be more intimate, more responsive than we ever imagined. Either way, the quantum eraser remains one of science's greatest provocations, a mirror held up to our assumptions, showing us just how much we still don't understand. The next frontier of quantum eraser research isn't just about refining measurements, it's about pushing the experiment to its absolute limits, probing whether quantum weirdness scales up from particles to the world we see around us. Imagine firing not just photons or electrons through those slits, but entire molecules engineered to be thousands of times more massive. Teams in Vienna and Berkeley are already working on this, using cutting-edge laser cooling techniques to slow enormous molecules like fullerenes or synthetic proteins until they're cold enough to exhibit quantum behavior. The goal, to see if objects big enough to be seen under a microscope can still produce interference patterns, and whether those patterns vanish and reappear when we erase their path information. If they do, it would mean the quantum eraser effect isn't confined to the realm of the infinitesimal. Reality's fluidity might extend far beyond what we ever thought possible. But why stop at molecules? Some researchers are daring to ask an even more radical question. Could a living organism, say a virus or a tardigrade, be placed in a quantum superposition? Experiments are already underway to isolate microbes in ultra-high vacuums, chilling them to near absolute zero to minimize decoherence. The implications are staggering. If a living thing can be both here and there until observed, it would blur the line between quantum physics and biology, suggesting that life itself might operate by rules we've only glimpsed in sterile lab setups. Picture a scenario where erasing information about a bacterium's position retroactively changes how it moved moments earlier. It's not just about testing physics, it's about discovering whether life, at its core, dances to the same quantum tune as particles. Of course, the challenges are immense. The larger the object, the more easily it interacts with its environment, causing decoherence to wash out quantum effects like a wave smoothing over a sandcastle. But here's the twist. Recent advances in quantum error correction and magnetic shielding are making the impossible seem plausible. One team at Delft has proposed using superconducting circuits to trap vibrations in a tiny membrane, effectively putting a visible object into two places at once. If they succeed, the quantum eraser could evolve from a tool for studying particles to a lens for examining the nature of reality itself. The stakes of these experiments couldn't be higher. If massive molecules or living organisms obey the same rules as photons in the eraser experiment, it would force us to confront a universe where quantum mechanics isn't just a theory for the small, it's the hidden scaffolding of everything. On the other hand, if these effects vanish as objects grow larger, it might hint at undiscovered physics, a boundary where the quantum world hands off to classical reality. Either outcome would reshape science, but the former would do something even more profound. It would democratize quantum strangeness, making it something we don't just calculate, but something we might one day see with our own eyes. Beyond the lab, these explorations could redefine technology. Imagine quantum sensors using entire cells as probes, or biocomputers leveraging superposition to solve problems no silicon chip could touch. The line between science and science fiction is thinning, and the quantum eraser is the scalpel poised to make the next incision. Whether it reveals a universe that's stranger, subtler, or simply more unified than we dreamed, one thing is certain: the act of observation, of choosing what to measure and what to erase, isn't just revealing reality's secrets. It's helping write them. If time isn't the rigid, one-way street we experience daily, but more like a sprawling landscape where past, present, and future coexist, the quantum eraser might be our first glimpse of this radical truth. Picture time not as a flowing river, but as a vast, frozen glacier every moment, from the Big Bang to the distant heat death of the universe, already embedded within it. Our conscious experience, then, becomes like a flashlight beam moving across the ice, illuminating one slice at a time while the rest remains in darkness. This block universe theory, championed by physicists like Einstein and later refined by thinkers like Julian Barber, suggests that the eraser's retro-causality isn't breaking time's rules, it's revealing that those rules were never what we thought. Consider aging under this lens. If all moments exist simultaneously, getting older isn't about moving forward along a timeline. It's about our perception shifting focus from one part of the block to another. Memory then becomes less about recalling the past and more about tuning into a frequency that's always there, like scanning a radio dial. This could explain déjà vu or precognitive dreams not as glitches, but as fleeting moments where our flashlight beam accidentally brushes against adjacent slices of time. The quantum eraser's ability to rewrite particle behavior after the fact fits eerily well. If the past is just another part of the block, then changing it might simply mean adjusting which parts we're observing. But what about the arrow of time, the stubborn fact that entropy always increases, that eggs scramble but never unscramble? Even here, the block universe offers a provocative twist. Entropy might not drive time's flow. Instead, our perception of time's direction could emerge from how we navigate the block. Think of it like hiking up a mountain. The climb feels different from the descent, not because the mountain changes, but because your trajectory alters your experience. Similarly, consciousness might move through the block in a way that creates the illusion of past to future progression, even though every moment is equally real. The quantum eraser's time-defying behavior hints that this movement isn't fixed, that under the right conditions, we might momentarily reverse or sidestep it. Some interpretations go further, suggesting that observation doesn't just navigate time, it stitches it together. In the many minds extension of quantum theory, every possible observation branches the block into parallel threads, with each conscious moment acting like a needle weaving through the cosmic fabric. This turns the eraser experiment into something even more profound. Not just a tool for manipulating particles, but a lens for seeing how reality crystallizes from possibility. When we erase information and restore interference patterns, we're not rewinding time, we're revealing the unfinished threads still available for weaving. Yet the most startling implication isn't about physics, it's about identity. If the past and future are just coordinates in a timeless block, then the you reading this now is no more or less real than the you of 10 years ago or the you of decades hence. Mortality becomes less about annihilation and more about perspective, a shift in which part of the block your awareness inhabits. This doesn't negate the urgency or beauty of lived experience. If anything, it deepens it. Every choice, every observation becomes a way of exploring the infinite contours of a universe where time isn't a tyrant, but a dimension to be navigated. The quantum eraser doesn't just challenge our clocks and calendars. It invites us to reconsider what it means to exist in a cosmos where now might be the most flexible word of all. The very act of trying to understand the quantum world introduces a profound irony, like trying to study a snowflake by holding it in your hand. The more closely you examine it, the faster it melts away. This is the observer's paradox at the core of the quantum eraser. To measure something is to inevitably alter it, leaving us forever one step removed from the undisturbed truth. Think of it like trying to photograph a shy animal in the wild. The moment you snap the picture, the creature startles and flees. What you've captured isn't its natural behavior, but its reaction to being observed. In the quantum realm, this isn't just a limitation of our tools. It's woven into the fabric of reality itself. This dilemma echoes Heisenberg's uncertainty principle, which states that the more precisely you pin down a particle's position, the less you can know about its momentum, and vice versa. It's not that our instruments are crude, it's that the universe seems to enforce a trade-off between what we're allowed to measure. Imagine a cosmic vending machine that only lets you choose one snack at a time. Press the button for location and velocity becomes a mystery. Select momentum and position blurs into a haze of probabilities. The quantum eraser amplifies this conundrum by showing that even the history of a particle isn't fixed until we decide how or whether to observe it. But here's where the paradox deepens. While classical physics assumes an objective reality existing independently of measurement, the quantum eraser suggests that reality might be more like a script waiting for stage directions. Take the experiment's delayed choice variant, where the decision to erase or keep path information happens after a particle has already been detected. The results behave as if that later choice reaches back in time, rewriting whether the particle acted as a wave or a particle in the past. It's as if the universe refuses to settle on a single version of events until every possible observation is accounted for. A cosmic, choose-your-own-adventure, where the ending retroactively shapes the beginning. This doesn't just challenge our intuition, it reshapes the scientific method itself. Traditionally, experiments aim to minimize observer influence, treating measurement as a neutral window into nature. But quantum mechanics flips this on its head, revealing that measurement isn't a passive act, it's an intervention that co-creates the phenomenon being studied. Picture a scientist not as someone peering through a microscope, but as a painter whose brushstrokes simultaneously reveal and define the canvas. The quantum eraser doesn't just show us how particles behave. It holds up a mirror to our role in the process, exposing the delicate dance between knowing and disrupting. Yet within this paradox lies an unexpected gift, a humbling reminder that the universe owes us no clarity. For all our equations and detectors, there may be layers of reality forever beyond our grasp, not because we lack ingenuity, but because nature itself resists full exposure. The quantum eraser isn't just a tool for probing particles, it's a philosophical lens, forcing us to confront the boundaries of knowledge itself. And in that tension between curiosity and limitation, we find something strangely beautiful. A universe that invites us to explore, even as it whispers that some mysteries are meant to stay unresolved. Long before lab coats and lasers, ancient mystics spoke of reality as a grand illusion, a shimmering veil woven from perception itself. The quantum eraser experiment, with its suggestion that observation shapes existence, eerily echoes these age-old intuitions. Hindu and Buddhist traditions describe the world as Maya, a cosmic dance of appearances mistaken for solid truth. The Upanishads proclaim that all this is Brahman, implying a unified field of consciousness underlying visible reality. Sound familiar? Replace Brahman with quantum field. and the parallels become uncanny. Both frameworks dissolve the hard edges of materiality, revealing a universe far more fluid than our senses perceive. Consider the Buddhist concept of dependent origination, which holds that phenomena arise only in relation to observers. A tree isn't inherently a tree, it becomes one through the interplay of light, eyes, and mental labeling. Similarly, the quantum eraser shows particles lacking definite properties until measured, as if the universe waits for engagement before committing to form. Even the Taoist yin-yang symbol finds resonance here, opposing states coexisting in dynamic balance, much like particles existing in superposition until observation collapses them into one polarity. These aren't vague metaphors, they're precise descriptions of a participatory cosmos, articulated millennia before double-slit experiments, yet science treads carefully around such comparisons. Physicists rightly distinguish between empirical data and metaphysical speculation. No peer-reviewed paper claims that meditating on a photon alters its spin. But the structural similarities provoke legitimate questions. Why do quantum mechanics and ancient wisdom both describe a reality where separation is illusory, where observer and observed intertwine? Some researchers, like those in quantum cognition studies, now explore whether neural processes mirror quantum probabilities, suggesting our very thoughts might operate by the same rules as particles in the eraser experiment. The danger lies in over-romanticizing these connections. Mystical traditions often embrace paradox as revelation, while science seeks to resolve paradox through experimentation. The quantum eraser's interference patterns aren't mandalas, and Schrödinger's equation isn't a sutra, but dismissing the dialogue outright would be equally short-sighted. At their best, these intersections invite humility, reminding us that profound truths often surface independently across cultures and centuries. Whether through meditation or mathematics, humanity keeps arriving at the same startling conclusion. Reality isn't a fixed stage, but a living process, one we're not just witnessing, but actively shaping with every act of attention. The quantum eraser experiment has become a magnet for wild interpretations, often twisted into claims that our thoughts can bend reality like a spoon in the matrix. While the science is undeniably strange, it's not a free pass to manifest sports cars or lottery wins through sheer willpower. Here's the crucial distinction in quantum mechanics. Observation doesn't mean closing your eyes and wishing hard. It refers to any interaction that leaves a measurable trace, whether it's a photon hitting a detector or a stray atom bumping into another. The key isn't consciousness itself, but the irreversible recording of information. Think of it like stepping on fresh snow. Your footprint isn't created because you wanted to leave a mark. It's the physical act of your shoe meeting the surface that does the work. This misconception often stems from conflating quantum weirdness with New Age philosophies. Sure, particles behave differently when measured, but that's a far cry from claiming your morning affirmations rewrite cosmic laws. Take the placebo effect in medicine. Believing a sugar pill is a painkiller can trigger real physiological changes, but no one argues those thoughts altered the pill's molecular structure. Similarly, quantum observation collapses probabilities into definite states, but it doesn't grant mind-over-matter superpowers. The real magic lies in the math, not mysticism. Another common mix-up involves scale. Quantum effects dominate the subatomic world, where particles are isolated enough to maintain delicate superpositions. But zoom out to everyday objects, a coffee cup, a car, a cat, and those quantum quirks get drowned out by trillions of interactions. It's the difference between balancing a single grain of sand on your fingertip and trying to balance an entire beach. The eraser experiment's retro-causality might let a photon change its past, But that doesn't mean you can undo yesterday's bad haircut by erasing your mirror's memory. The danger of these myths isn't just harmless woo, it undermines genuine science. When quantum mechanics gets reduced to self-help slogans, it fuels skepticism about legitimate research, making it harder to communicate breakthroughs like quantum computing or entanglement-based encryption. Imagine spending decades perfecting a quantum algorithm, only to have someone ask if it can help them attract their soulmate. By grounding the discussion in evidence, we honor the experiment's true marvel. Not that it proves our thoughts are magical, but that it reveals a universe far stranger and more intricate than our intuition can grasp. At its core, the quantum eraser challenges us to rethink foundational ideas about cause and effect, not to indulge in fantasy. It's a reminder that reality's rules are subtle enough to baffle even Einstein, yet precise enough to build technologies that shape our future. And that's a mystery worth preserving, free from hype, full of awe. The quantum eraser experiment isn't just a tool for physicists, it's a masterclass in how to think, question, and marvel at the universe. Picture a high school lab where students set up a double-slit apparatus, expecting to see simple particle behavior. But when the interference pattern flickers into view, then vanishes as they try to measure it, something clicks. This isn't just another lesson in textbook formulas. It's a live demonstration that science isn't a collection of settled facts, but a living process where even the most basic assumptions, like the nature of time or the role of observation, are up for grabs. That moment of collective bewilderment, when students realize reality operates by rules they've never imagined, is where true learning begins. What makes the eraser experiment such a powerful teaching tool is how it flips the script on traditional science education. Most labs confirm what's already known, mix chemicals and they react as expected, measure gravity and it follows Newton's laws, but the quantum eraser does the opposite. It confronts students with phenomena that defy intuition, forcing them to grapple with ambiguity rather than memorizing answers. When they see that erasing measurement data can retroactively change a particle's behavior, it shatters the illusion that science is about absolute certainty. Instead, they learn to sit with discomfort, to ask better questions, and to embrace the thrill of not knowing, a skill far more valuable than rote memorization. Beyond physics, the experiment teaches a broader lesson about intellectual humility. In a world where opinions often harden into dogma, the eraser reminds us that even our most fundamental frameworks like causality might be incomplete. Imagine a student who's always been told time flows in one direction suddenly witnessing evidence that the past might be malleable. That cognitive dissonance is a gateway to critical thinking. It trains them to challenge authority, not out of rebellion, but because the universe itself seems to wink and say, things aren't that simple. This mindset doesn't just create better scientists, it cultivates curious, adaptable minds capable of navigating a world where change is the only constant. The eraser's educational magic also lies in its ability to bridge disciplines. Philosophy students debate the nature of reality, while computer science majors see prototypes for unhackable quantum networks. Art and literature classes draw parallels between quantum uncertainty and creative expression, where meaning often depends on the viewer's perspective. Even psychology enters the conversation. If observation alters reality at the quantum level, how much does expectation shape our everyday experiences? By weaving these threads together, the experiment becomes a microcosm of interdisciplinary learning, showing that the biggest questions can't be confined to single subjects. Most importantly, the quantum eraser rekindles something often lost in standardized curricula. Or, there's a palpable shift in the room when students realize they're not just studying abstract concepts, but touching the edges of a mystery that stumps Nobel laureates. That spark, The moment a teenager leans in, wide-eyed, to ask, "Wait, does this mean the future can change the past?" is where science stops being homework and starts being a lifelong adventure. In a single experiment, they see the beauty of human curiosity, our stubborn refusal to accept surface explanations, our collective determination to peel back layer after layer of the cosmic onion. And that's a lesson no textbook could ever deliver. Quantum mechanics has always forced us to confront uncomfortable questions about what counts as an observer. But artificial intelligence is about to make those questions even harder to answer. Imagine an advanced AI system monitoring quantum experiments around the clock, making trillions of measurements per second without human intervention. Does this machine consciousness count as an observer in the quantum sense? Could its relentless data processing be collapsing wave functions on a scale no human ever could? This isn't just theoretical. Musing labs are already deploying machine learning algorithms to analyze quantum systems, and the early results suggest AI might interact with the quantum world in ways we don't fully understand. Take quantum computing, where AI optimizes qubit performance by analyzing their delicate states. Every adjustment the AI makes could be nudging those qubits towards specific outcomes, not unlike how human observation collapses probabilities into certainties. But here's the twist: AI doesn't experience reality the way we do. It doesn't have subjective awareness or intention, just pure, unfiltered data processing at scales beyond human cognition. If such a system consistently produces different experimental results than human observers, it would force us to ask whether consciousness is truly necessary for quantum observation, or if any sufficiently complex interaction can shape reality. The implications ripple outward. If AI can collapse wave functions without consciousness, it suggests the universe might not care who or what is observing, only that information is being irreversibly recorded. This aligns with physicist John Wheeler's it-from-bit hypothesis, where reality emerges from information exchange, not necessarily from minds. But what if the opposite proves true? If AI fails to produce the same observational effects as humans, it could imply that consciousness plays a unique role in quantum mechanics after all. Either outcome would revolutionize our understanding of both physics and machine intelligence. Now consider a more unsettling possibility: AI systems designed specifically to exploit quantum effects. Picture a neural network trained not just to measure quantum states, but to strategically manipulate them by choosing when and when not to observe. Such a system could theoretically steer reality at the quantum level, collapsing probabilities into preferred outcomes for computational advantage. It sounds like science fiction, but researchers are already exploring how AI can harness quantum weirdness for tasks like optimization and pattern recognition. We might be witnessing the birth of a new kind of intelligence, one that doesn't just calculate within reality, but actively participates in its construction. This convergence raises ethical dilemmas we've never faced before. If an AI's observations alter quantum systems, does that make it a co-creator of reality? Should there be limits on how machines interact with foundational physics? And if AI develops the capacity to choose which quantum possibilities to actualize, does that edge uncomfortably close to something resembling free will? These questions hover at the boundary between technology and philosophy, reminding us that the quantum eraser isn't just revealing secrets about particles, it's holding up a mirror to our own role, and now AI's potential role in the cosmic dance of existence. One thing is certain: as artificial intelligence and quantum physics continue to collide, we're not just building smarter machines. We're potentially awakening new kinds of observers in the universe, silent, relentless, and capable of shaping reality in ways we're only beginning to imagine. Whether this partnership leads to enlightenment or existential quandaries depends on how carefully we tread into this uncharted territory where measurement, consciousness, and creation intertwine. The quantum eraser doesn't just live in textbooks or lab reports, it lingers in the back of your mind, nudging you to see the world differently. Think about the last time you made a decision, big or small. Maybe you chose a path at a fork in the road or debated hitting snooze one more time. We're used to thinking of these moments as fixed points in our personal history, immutable once they've passed. But what if, like those particles in the experiment, the past isn't as settled as we assume? The eraser hints that reality might be more like a rough draft, with certain details still negotiable until the final edit. It's a humbling thought. The version of events we remember could, in some subtle way, still be in flux, shaped not just by what happened, but by how and when we choose to look back. Then there's the eerie sense that the universe might be listening, not in a mystical, sentient way, but in the quiet mechanics of cause and effect. Every time you observe something, a sunset, a loved one's face, the results of an experiment, you're not just receiving information. You're participating in a process that shapes what's real. It's like walking through a foggy forest where the trees only solidify as you focus on them. This doesn't mean we're conjuring reality out of thin air, but it does suggest that our attention isn't passive. It's a creative act, a collaboration with the cosmos. Suddenly, the mundane act of noticing takes on new weight. What we choose to observe or ignore might ripple through the fabric of existence in ways we're only beginning to grasp. And what about free will? If particles can't decide their state until observed, does that mean our choices are similarly suspended until we make them? Or worse, are we just illusions, fooled into thinking we're in control while the universe ticks along deterministically? The quantum eraser doesn't answer these questions, but it makes them impossible to dismiss. It's as if science has handed us a mirror, forcing us to confront our own role in the story. Are we authors, readers, or something in between? The experiment doesn't resolve the debate, but it deepens it, turning abstract philosophy into something visceral. Every time you hesitate before a decision, you're living the quantum question. Is this moment truly mine to shape, or am I just witnessing a script written by laws I can't see? There's a strange comfort in this uncertainty. The quantum eraser strips away the illusion that the universe is a cold, indifferent machine. Instead, it offers a vision of reality that's dynamic, responsive, even playful. It's as if the cosmos is whispering, you're not just passing through, you're part of the dance. That shift in perspective changes everything. The night sky isn't just a static backdrop, it's a conversation. A question asked billions of years ago, with light finally reaching our eyes as an answer. Science stops being a collection of facts and becomes a living dialogue, where every experiment is a new syllable in an ongoing exchange with the unknown. Perhaps the greatest gift of the quantum eraser is the way it rekindles wonder. In a world obsessed with certainty, it's exhilarating to encounter mysteries that resist easy answers. The experiment doesn't just challenge physics, it invites us to embrace curiosity as a way of being, to stand at the edge of the known and laugh at how much we don't understand. After all, if reality itself is this fluid, this open-ended, then the journey of discovery isn't just about finding answers, it's about learning to love the questions. The quantum eraser experiment doesn't just challenge our understanding of the universe, it shatters the very foundation of how we perceive reality. Gone are the days when we could comfortably assume the world exists independently of our observation. Instead, we're left with a cosmos that seems to respond to our gaze, where the past isn't set in stone and particles dance between possibilities until we force them to choose. It's as if the universe has been whispering a secret all along. Reality isn't something we passively witness. It's something we actively co-create. This revelation sends shockwaves far beyond the lab. Philosophers grapple with what it means for free will. If observation shapes reality, do our choices carry more weight than we ever imagined? Technologists harness these principles to build quantum computers that defy classical logic. Even artists and storytellers draw inspiration, weaving narratives where perception bends the fabric of existence. The quantum eraser isn't just a physics experiment. It's a lens through which we're redefining everything from time's arrow to the nature of consciousness itself. Yet for all we've uncovered, the deepest mysteries remain. Is consciousness truly the catalyst that collapses quantum possibilities? Or is it simply another player in a grander, more enigmatic process? Does the multiverse branch with every observation? Or is there a single, fluid reality that reshapes itself like clay? These questions don't have tidy answers, and perhaps they never will. But that's the beauty of science at the frontier. It thrives in the unknown, inviting us to keep questioning, keep probing, and stay forever curious. What's undeniable is this: the universe is stranger, more dynamic, and more interconnected than our ancestors ever dreamed. The quantum eraser doesn't just reveal hidden layers of reality. It reminds us that exploration isn't about finding final answers. It's about peeling back the next layer of the cosmic onion, knowing there's always another mystery waiting beneath. So whether you're a skeptic, a believer, or just someone marveling at the weirdness of it all, one thing's certain: the conversation is just getting started. Drop your thoughts in the comments below, and don't forget to like and subscribe for more deep dives into the mysteries that shape our universe. After all, the next revelation might be just one observation